Hello, good morning. Electroanalytical methods. Change in the electrical properties of the system is principle of electroanalytical method, and properties like mass of the deposited substance is measured. This electroanalytical technique is also again further divided into flowing, classification of electroanalytical methods: electrogravimetry, colorimetry, conductimetry, amperometry, potentiometry, polarography. Electrogravimetry measures the mass change of an electrode due to the deposition of an analyte. Principle: electrolysis carried out. Properties: material deposited on one of the electrode is worked. For example, electroplating to determine metal ion concentration. Colorimetry measures the total change passed through the system during an electrolytical reaction. Principal: deposition of matter on an electrode during electrolysis. Properties: quantity of electricity and time. For example, determination of water content by Karl-Fischer titration. Conductimetry: change in electrical conductivity of a solution during chemical reaction and measured electrical conductivity. Principal: change in electrical conductivity of a solution during the chemical reaction. Properties: electrical conductivity, electrical resistance. Measures the conductivity of solution to determine the concentration of ionic species. Example, monitoring water purity. Amperometry: potential applied between the indicator electrode is kept constant. Amperometry is used to measure current through the electrolytic cell. Principal: potential applied between the indicator electrode and depolarized reference electrode is kept constant. Properties: measured current through the electrolytic cell is measured. Measures the current generated by the oxidation or reduction of an analyte at a constant potential. Measures the constraint generated by the oxidation or reduction of an analyte at a constant potential. Example, glucose sensors in blood analysis. Potentiometry: it is change in the electrode potential of the system during the chemical reaction or the measurement of electrical potential as a technique in chemical analysis. Principal: change in electrode potential of a system during the chemical reaction. Property: measure electrode potential. Measures the electrical potential of a solution without passing a current. Example, pH measurement using a glass electrode. Polarography is based on electrode polarization, electrochemical reduction, oxidation principle, and explained using Elkovic equation. Polarography is to measure electrode potential, voltage, current. Principal: electrode polarization. Property: measured voltage, current. Electrode polarization refers to a phenomenon that occurs during the electrochemical process when the behavior of an electrode deviates from the ideal electrochemical behavior due to various factors like overpotential and concentration gradient at the electrode interface. Overpotential occurs when the applied potential at the electrode solution interface is different from the thermodynamic potential required for an electrochemical reaction to proceed. This additional potential is needed to overcome the activation energy barrier for the reaction. Overpotential can lead to slower reaction rates and can be influenced by factors like electrode surface properties, temperature, and the nature of electrochemical reaction. Concentration gradient or polarization occurs due to the accumulation ions or molecules near the electrode surface during the electrochemical reaction. As the reaction proceeds, the concentration of these species can change, leading to a concentration gradient of the electrode. This gradient can create an additional potential difference that opposes the desired electrochemical reaction. Concentration polarization can be decreased by stirring the solution or using the rotating electrode to improve mass transport to the end from the electrode surface. Polarization is used to measure electrode potential, voltage current, application of electroanalytical chemistry, environmental monitoring, detection of heavy metals and pollutants in water, biological studies measuring neurotransmitters, glucose levels, or DNA interactions, industrial process, quality control in electroplating and battery manufacturing, pharmaceuticals, analyzing drug formulations and impurities. Okay, it's all about electroanalytical methods. Electroanalytical methods. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now bye bye.